So today we'll discuss about the different forms of energy. Okay, so that is the second part of work part energy chapter. So different forms of energy. So in the previous part only we have discussed about what is energy, that is the capacity or the ability of doing work. Now we'll discuss about the different forms of energy. Here we will discuss about the different forms of mechanical energy. What is mechanical energy? Mechanical energy is basically the ability or capacity by which we can able to do some mechanical work. Okay, that is known as mechanical energy. So how many types of mechanical energies are there? If I see the type, that mechanical energy is of two types. One is known as potential energy and another one known as kinetic energy. What is potential energy? We all know, we have read it earlier also, the energy possessed by a body due to its state of rest by changing the shape and size of a body or by changing the position, that is known as potential energy. Okay, so simple thing, if I take a body to a height, then the body will gain some potential energy. If I compress a spring, then also due to the change of shape and size, the body will gain some potential energy. So I'm not going to discuss much example of this matter because you have already learned it earlier. Here we have to see the types of potential energy. So there are two kinds of potential energies are there in generally. One is known as gravitational potential energy and another one is known as, that is, elastic potential energy. Now we're coming to gravitational potential energy. What is gravitational potential energy? That if we have done some work against the force of gravity, then the energy possessed by a body, that is known as gravitational potential energy. Okay, if we have done some work against the gravitational force or gravitational field of earth, okay, then the energy possessed by it, possessed by a body, that is known as gravitational potential energy. Okay, now how can we able to measure it? See, I'm just making you remember, in the previous part we have done one calculation that if a mass of m is taken to a height of h. Okay, so in here what work we have done? We have done the work is mgh. So if we have done the work mgh, that work should be stored on the body as its energy. So potential energy is also mgh. So the derivation we have done earlier, so we will not go much or to discuss about the derivation because we have already learned it. Coming about the next one, elastic potential energy. What is elastic potential energy? I'm telling you earlier that elastic potential energy is possessed by a body when the energy is possessed due to the change of shape and size of a body. Due to the change of shape and size of a body, that one is known as elastic potential energy. So if I am asking what is the example of it, so as we are talking about the example like compression of spring, or you can say compression or expansion of the rubber band, that all are elastic potential energy. Compression or expansion, all everywhere. Okay, now we have to discuss about kinetic energy because see, potential energy is comparatively easier for us. Now we will discuss about the kinetic energy. What is kinetic energy? The kinetic energy is the energy which is possessed due to the motion of a body. The energy is possessed due to the motion of a body, that is known as kinetic energy. Now we have to see the types also. How many types of kinetic energies are there? So due to the translational motion, if the body moves in a straight path, then the kinetic energy is processed, that is called translational kinetic energy. Number two, if the body rotates, and that is known as rotational kinetic energy. And if the body vibrates, that is vibrational kinetic energy. So three kinds of kinetic energies are there: translational, rotational, vibrational. So here we'll not learn about the rotational, means we have not done any sort of calculation on rotational kinetic energy or on vibrational kinetic energy. We have to learn about translational kinetic energy, and we have to derive a formula by which we can able to learn what should be the value of translational kinetic energy. Let's see the calculation first. Okay, so here our target is to find out the expression of kinetic energy, and when we are talking about kinetic energy, it is simply translational kinetic energy. So we have to write here expression of kinetic energy. Assume a body whose mass is m. It is moving with a velocity of v, okay, through a path. Suddenly, you have applied a force against the body, and the force is F. And as we have applied a force against the body, there will be a retardation created, because if the force is applied against the motion, there will be a retardation A, and due to that the body cover a distance of s and it stops. Okay, and now the velocity is 0. Okay, that is the story. A body of mass m is moving with a velocity v, and then a force F is acting against the motion of the body, and that's why a retardation A is produced. For that reason, after covering distance S, the body stops. Okay, if it is asked to you how much work is done against the body, see, you have applied a force F and the body displaces by S. So that means your work done should be F into S. That is your work done. Acha, how much work you have done against the body, that should be stored on the body as its energy, right? Because the body possesses that much energy, so to oppose the energy you have to do that much amount of work. Okay, so here you can ask that you have not taken the minus sign, because the displacement and force exactly opposite to each other. We have not taken minus sign because we just want to take the magnitude. Okay, so we can say the work done against the body should be equal to the energy possessed by the body. Simple thing. Now how we can able to find the work done? Okay, let's see. Here from the information we can say the initial velocity is u equals to small v, because initially the body is moving with v. Final velocity small v is equals to 0. Finally the body gone to 0. Displacement is equals to s, and here we can say the retardation is equals to a. So we can use one equation, that is v squared equals to u squared minus 2as. So here we have taken minus because it is a motion of retardation. That's why the minus sign has come. So if I put the values as per the thing is given, so v square it is 0, u square it is small v square minus of 2 into a into s, or 2 into a into s equals to small v square. Okay, and now if I have taken a into s, it is equals to half of v square. Now what we have done, we are multiplying by m in both sides. So m is the mass of the body, multiplying by m, both sides we have multiplying the m. So here it will come m into a into s equals to half of m into v square. Okay, m into a, what is it? We know F equals to m into a, force. So instead of m into a, we can write Fs equals to half mv square. Fs is the work done, and we know what is work done on the body, that should be the energy. So it will be the kinetic energy. So kinetic energy of a body is half mv square. That is the equation of kinetic energy. Okay, I think it is clear enough. Clear? Now we'll go and find the relationship between kinetic energy and momentum. So the equation of kinetic energy we got half mv square. We'll go to the next part. What is the next part? The next part is kinetic energy and momentum's relationship. See, just now we have seen that kinetic energy Ke is equals to half mv square, right? And again momentum P equals to m into v. We know the product of mass and velocity is known as momentum. So from here we can conclude two things. It is equation number 1, it is equation number 2. So we can write from equation 1. From equation 1, can we write down 2 of kinetic energy equals to m into v square. See, 2 is multiplied here. And now multiplying by m in both sides. If we multiply m, so here no need to say much thing, we have to do the calculation. So we are multiplying m in both sides to twice m into Ke, that equals to m square v square, right? Now you see m square v square equals to mv whole square. So mv whole square is what? It is the momentum square, that is p square. P square equals to twice m into kinetic energy, and from here P equals to root over of twice m into kinetic energy. Or in other way, from here we can write down kinetic energy is equals to P square by 2m. Okay, so this is the relation between momentum and kinetic energy. In numerical we can use any of the equation because both the equations are same. Any of the equation we can able to use in numericals. Okay, so that is the relation between kinetic energy and momentum. Now I'll go to the third thing, and it is very important one, that is work energy theorem. Okay, the third thing we have to learn here, that is work energy theorem. What is the work energy theorem? Work energy theorem is basically a relationship between work done and kinetic energy. It is a relation between work done and kinetic energy. We have just learned that what work we have done, that work is stored on a body as its energy, but how we can able to prove it. So for proving, you have to use the work energy theorem. So before that, we have to learn the statement of work energy theorem. The statement tells us that work energy theorem means the work done by a force on a moving body is equal to the increase of kinetic energy. That means how much work you have done on a body, that will increase its kinetic energy. So let's see an example. Assume same thing, a body of mass m is moving with a velocity u. Now you are applying force on it. Okay, and due to application of force F, it got an acceleration A, and it covers the distance of S, and there the velocity of the body is changed to V. Simple thing. The logic is very easy. Mass is m, initial velocity is u, force applied F, and due to the application of force, the body displaces by s distance, and then the velocity is increased by v due to the acceleration of A. A very easy idea. Now the question has come, what things we have to calculate from here. First we have to calculate the work done, how much work we have done on the body. Now simply we are applying a force F and it is displaced by a distance S. So your work done is F into S. Now the things is given, that is initial velocity, that is equals to u, final velocity is equals to v, acceleration, that is equals to a, and displacement, that is equals to s. We have to use the same equation, v square equals to u square plus 2as. Here we have taken plus because this is all about accelerated motion, because in which direction force is applied, the body is displaced in same direction, so that is accelerated motion. That's why the plus sign is taken. If I put the value, see it already given, final velocity is v, initial velocity is u, acceleration is a, and displacement is s. We can write this thing that 2as equals to v square minus u square, or as equals to half of v square minus u square. If I multiply by m, similarly we have done the previous work, multiplying by m in both sides. So it will come MAS is equals to half of v square minus u square into m. M into a. We all know that F equals to m into a. So it is F into s, and if I multiply this thing, it will come half m v square minus half m u square. Fs equals to work, Fs equals to work done, W, and half mv square equals to, you see, v is the final velocity, so it is final kinetic energy, and half mu square, it is initial kinetic energy. So work done equals to final kinetic energy minus initial kinetic energy. So here we can conclude that work done is equals to change or increase in kinetic energy. The whole thing, it is known as work energy theorem. So work energy theorem is nothing but the relation between the work done and the energy. Now the next thing we'll learn, that is the difference between kinetic and potential energy. I think it is given any book. What is the difference between kinetic and potential energy? That kinetic energy is possessed when the body is moving. Potential energy is possessed when the body is in state of when it is in static position. Potential energy, kinetic energy, it is basically equal to the work done when a moving body can do before coming the rest. And potential energy, it is equal to the work done bringing the body to change the state. Okay, kinetic energy cannot be, it can be transformed from any another form, but potential energies just change to the form of kinetic energy only. Okay, and potential energy doesn't depend on the speed, kinetic energy depends on the speed of the body. So these are the difference between kinetic and potential energy. I think you are having book, just see it, you will get it. Now we'll just move the conversion of energy. I think it is the easiest part of your syllabus. Why? Because conversion of energy, I think you have learned it from class 6 or 7. Conversion of energy. What is conversion of energy? We know when the energy is converted from one form to another form, that is known as conversion of energy. It can be potential to kinetic, it can be any other form. Okay, so if I am talking about the example, assume the spring is compressed, it is having the potential energy, and when it is released, it is just hitting on a ball and the ball moves forward. So the potential energy of the potential energy of the spring is converted into kinetic energy of the ball. Okay, just like this thing, when you stretch a bow, then it possesses potential energy. When you release the bow, then the potential energy of the bow is converted into kinetic energy of the arrow. So that things we know. If I'm discussing about the different forms of energy, we know there are different forms of energies are there. Any form we can understand what we have learned earlier also, different forms of energy. So here we can say about solar energy, nuclear energy, hydro energy, electrical energy, heat energy, light energy, chemical energy. So these energies are explained. We are not going to explain this. Okay, and my suggestion is you have to read it and then only we can understand. Coming to the conversion of energy. Conversion of energy is comparatively very easier and you have learned earlier also. Just like if I am giving an example, give an example of mechanical energy to electrical energy. What should be that example will be? Mechanical energy to electrical energy, that should be dynamo or generator. If we are going to the reverse direction, that is electrical to mechanical, that is motor, electric motor, any of the electrical motor. If I am telling to electrical to heat energy, electrical energy to heat energy, so it is very easy. It can be electrical iron, it can be heater, any of the example. Electrical to sound, electrical energy to sound energy, that should be the loudspeaker. Okay, and the reverse is also we know that if sound energy to electrical energy, that is microphone. So these are the example. If I'm talking about chemical energy to light energy, that is candle. If I'm talking about chemical energy to electrical energy, it can be cell. If it is light energy to chemical energy, it is photosynthesis. So many more examples are there. Whatever the book you have used, if you read any of the book, there you will get this conversion of energies. So my suggestion is that go through the conversion of energies, whatever there in your book. I think it will be helpful for you. Okay, I don't write much on that because whatever the things I have written here, you know more than me. Okay, so go through the book, many more conversions are there, see it. I think it will be helpful for you.